Okay, restructuring and adding additional structure to the faceplate. So, therefore, replicating this faceplate to implement into here. The permanent magnets that's alongside the exterior will follow up in here. So I'm going to place the permanent magnets around the exterior that should synchronize the induction. The induction shall emit. I'm going to put the magnets sandwiched between two linear coils. The magnets will be localized at the top and at the bottom. The phase point shall wind upward and push against the permanent magnets. The permanent magnets having 2.6 kilograms, which should be way more than enough, like 5 pounds to lift each one. So each individual having 2.6 kilograms. There's 14. That should be 30. I believe that's 38 kilograms. Point something 38 kilograms and some odd ounces. So 38 kilograms actually to lift this. That's a lot of force. And so 30 kilograms, 30 kilograms, 30 kilograms, 30 kilograms, 30 kilograms, 30 kilograms, 30 kilograms. Now, as of the vortex, the reason why I have the vortex here, see how the stator is driven for the circuit. This will send current to phase the linear motor. And the linear motor that will bear the permanent magnets shall cause it to move upwardly and suspend it. Now, having both on the side where I have pull and push force. Pull and push force will allow it to have static while it's suspended into the air. Now, this for example, using a linear motor, which is linear motor, and having one on the top and one on the bottom. Now, the permanent magnets will be localized at the top of here, which will enable the linear motor to push against the magnetic field and force it up. However, at the same time, simultaneously, the pull and push forces solenoid pole, where around there synchronizes the induction of the linear motor and causes it to lift. There it has static to magnetic spin, pull and push forces in the linear motion. So, recreating this to fabricate it, and it's much lighter. I'm only using one, so I don't have to have a stack here for the commutator. Now, as of the ball bearing bracket, where I'm going to have a rotary within the system, I'll apply the T-bar and the ball bearing so I can be able to cool the area within this vector, which only needs a small fan. So long as I use the permanent magnets along for the fan, it will rotate and synchronize the electromagnetic induction coil. Not only, but it will rotate and phase the linear motor. So the fan is shaped in vertical blades that doesn't have a pitch. It's actually vertical, and that will rotate around and cool off the blades, also cool off the induction, and also bearing permanent magnets, and causes both sides to be cooled. And then I can enclose it with a metal sheet over the housing, over both sides. So to close it up and link it with the bolts with the screw holes. And that will enable this structure to lift up into the air. My name is Jermaine Morton. Have a nice day. Goodbye.